Hello, and welcome to the SSPI Git Basics tutorial. I'll be taking you through the basics with Git. So, I'm going to assume that you can run code on your machine. I know that's not always the easiest thing to assume because a lot of courses are taught basically completely in the browser, which is kind of scary, but, you know, that is where we're at. I'm going to assume you have these kinds of things installed. Follow the links if you don't have them installed. And yeah, so Git is a free and open source distributed version control system. So what does that mean? Free and open source means that it is developed in public by a community of programmers. They collaborate openly, and the source code is openly available to all who wish to modify it. And if you make some really good changes to it, there's a chance those changes get merged into the final product. So it's the product of many people coming together to make a thing. It's pretty cool. It is a distributed version control system in that you actually have all of the files from your project on your computer. And that is different from, say, Google Docs. So if you're using Google Docs, those files live on Google's computer, not on your computer. And to access your files, you have to go to Google's computer by navigating to docs.google.com and using the interface there. And you don't get a lot of the version control benefits. I mean, you can look at your change history, but if Google were to go away, or, you know, their servers were to go down, or they somehow lost your data, which does happen from time to time, although, you know, it's not super likely, you would lose those changes because you don't actually have them on your computer. A distributed version control system, everybody collaborating on the project has their own version of the file history, the version history, and the local file tree. So that's pretty cool. Maybe not the most efficient in certain circumstances. Like if you have a bunch of giant files and everyone has their own, you might say, why don't we centralize them all? And that's a thing people do. But for most projects of most people's scale, Git is actually really cool because everyone has their local versions. They don't need an internet connection to edit the files. They don't have to worry that, like, I'm editing offline. What happens when we have to merge back in? There's a whole procedure set up to handle that. And it's version control system, which means we can go back to every point in history of the project. We can track different changes throughout the history, and we can kind of, move around, and everything's tracked. Everything is taken care of. So all states are recoverable, and we can make certain guarantees about not losing our work, which is really good. So let's talk about the basic mental model for using Git. So what is Git repository? A Git repository is just a folder. So this is a folder on my machine. This is my SSPI main folder. And it's a Git repository because I've run git init in here, and I've made some commits. And all of those changes are tracked inside of this fancy here Git folder, which has some stuff in it. So if we ls.git, then you can see there's a bunch of stuff in there. I typically don't poke around in there because there's nothing for me. All of it is kind of managed internally by Git. But yeah, that's how you enable a Git repository. It's super simple, and it's just some files, so nothing too crazy. So, Git is, the basic unit in Git is a commit. So if I look at the Git log, you can see there's a large set of commits here. So you can see I've got a commit, and then every commit has an author, a date, and a description. So a message, and it can be multiple lines, your message. It can be quite descriptive. None of these are very good commit messages, all things considered, but they're not so bad. This is the commit hash. It is generated based on all of the things contained in the commit, and it's a unique identifier. So you'll sometimes see these hashes used to, here, let's go here. These hashes, maybe just even the first 6 letters or so, 1, 5, 6, something like that. These can be used to uniquely identify commits in your repository, which is really nice. So that's a handy thing to know how to get. And there are some conventions for making nice commit messages. You'll see that these are not following those conventions as well as they could, but as we get better at Git, we'll try and do it more. So let's continue on. We're looking at the log right now, and we can view the log in one-line format. So that's kind of handy if you're just maybe browsing through, what has happened in this repository, what's going on. You can see all of the different messages and the little hashes on the left-hand side. So those are like 7 letters of the hash. So yeah, pretty useful. And you could also count the number of lines of that. So there are 24 commits in this repository. That is a very small number of commits. If we were to change over to our web app, which is, you know, where most of the development work goes on here, because that's where all the data lives, and also where all of the programming that makes the front end work lives, then we could look at the git log, and we could look at the one line, and you can see this goes on forever and ever. There are so many commits in here. How many, you ask? Well, I guess let's just do it that way. You can see that there are 1,800 commits. That little program is WC counting the lines, so word count counting lines. So since it's the one line, each line corresponds to a commit, yada, yada, yada. So we can also look at the stat. This will give you more detailed changes about what happened in each commit. So it can say there were 2 files changed, 24 insertions, and, 8 deletions. So, and I'll tell you which files actually changed, and it'll actually give you this nice little graphic with, you know, this one had a plus and a minus, and this one had a bunch of pluses and a bunch of minuses. So, cool. Those are different lines that actually changed in that particular commit. And so this gives rise to a sort of concept in Git about a commit. So a commit means sort of 2 different things at different stages. There is a commit as the state at a given period of time in the project. So the commit is like a save point, right? And it contains the whole history up to that point. And there's also this idea of a commit as just a set of a couple changes. And both of those things are true, and that's kind of the brilliance of the data structure that is behind Git. You can go to a commit, and it will be the whole history of the project up to that point, because each commit points back to its parent commit, but it also is quite a small object. It's just a set of changes. It's not actually the whole project history in some sense. But yeah, that is how Git works under the hood in a very schematic way. So let's look at this graph real quick. We'll worry much more about merging later, but you can actually see that different branches of the project, that's indicated by these nice little lines here, can be merged together. So different histories come together. You have some commits going this way, some commits going this way, different sets of changes evolving that then get merged back together. And that's really the killer feature of Git. That's why people, you know, use it for all of their coding, because you can actually work on different things in parallel in a big project full of structure, and then merge those things back together in an intelligent way. And the basic mental model we're going to use has 4 parts. So the first part is this working tree. So that's sort of the save points. Well, I shouldn't even call them save points. The working tree is just, you know, the changes you're making that are not being tracked by Git, basically. Like, there's no version control on these. This is just what you do in a file. So as an example, I suppose we should init a repository. So we'll go up here and we'll make a directory called test repo, and we'll cd into test repo. And you can see there's not anything here except, of course, our 2 little special guys. But what we can run is git init, and there is a little message here when you run git init that you should run this command too, and we'll change it to main. This is from some protests back a while ago that, you know, master is kind of evoking slavery, which definitely is. So yeah, just change your branch name if you're, you know, if you care about that kind of thing. So yeah, we changed the branch name. We're on Git. We can check status. So it'll say you are on branch main. You have no commits yet and nothing to commit. So why is that? Well, there's nothing in our folder except, of course, this new fancy .git folder. So if we ls.git, you'll see there's some stuff in here. And one thing that is important here is this idea of head. So where is head? Well, right now it doesn't point to anything because we have no commits, but your head will track the commit you are currently at. So that is something you might end up needing to know. But for now, don't worry too much about it. One thing we can do is we can actually, let's see, grab these here. I'm going to create some files just for fun. So let's run this little command. And so I've created 3 files doing that. I have file 1, file 2, and file 3, and those are just, you know, in my repo. So that's good to know. Each of those contains some things. So if I cat these. Cat is going to look at each of these things and put them together. So it's got 3 different lines. Each one has 1 line. So if I just open up my text editor, this one has this line. Let me go back here. Yeah, this one's got this line. My mark has an invalid line number. Don't worry about that. Oh, sorry about that. Okay, yeah, and this one has this line. So not a big deal, but that's the structure of those files. They're just text files. And so if we take a look at that, yeah. And so what is our git status once we've put those files in? Well, we have these untracked files. And so we want to decide what will be included in a commit because we have no commits yet. And the first thing we're going to do is add a file. So I have this example here. We're going to git add file1.txt. Now what does that do? That is going to move, that is going to move the file from the working tree into the staging area. So the way you sort of read these is, this is the state before, then we run this command, this is the state after. So now we have something in the staging area. If we git status, you'll see changes to be committed. This is the staging area. So we have 1 file staged for commit, that's file1.txt, and the other 2 files remain in the working tree, which not yet tracked. Cool. Now, the staging area is kind of a temporary location. You'll leave things. There's nothing permanent about it. If I want to reset it, it's really easy. I just say git reset, and now git status, there's nothing in the staging area. And so your staging area is sort of how you build nice commits. And when you're first starting out with Git, it's going to be tempting to just say something like this. You're going to say git add dot, right? You're just going to add everything you've changed in, and you're going to be like git commit -m saved or something like that. And this is a terrible commit. Like, you have no structure here, and your message is not super helpful. So it says saved. Great. Like, thank you for that. When I'm looking at this in a year, I will not have any idea what happened here. So let's just start fresh. So I'm going to just remove that. This is the thing you should never do. Git that .git folder because I want to retry doing this again. So I'm going to git init. I'll change my master branch name to main. So git status. Cool. So we're on the main branch. And now we're back to where we were at the start. So I didn't want that commit, which is why I got rid of that repo entirely. But don't delete your .git folder ever, unless you know what you're doing. So yeah, how do we add these things? We git add. You could see I do something like this. So I could do thing that has 1 in it and a thing that has 2 in it. This is globbing. So this is, file2.txt, something like that. And we check our git status. Then we have added these 2 files to our commits, or to our, we have added these 2 files to our staging area, and they are changes that are ready to be committed. Now we can git commit these things with a helpful message like added, let me just come on over. So I'll make sure we match the tutorial. Source first 2 lines of catalyst 1. This -m flag is saying that's my commit message. And now we have a commit. So if we look at our git log, you can see that we actually have this thing stored in here. And that's cool. So now we have a save point that has just these 2 files in it. If we git log stat, you can see that we have 1 added to each file. And so, yeah, this kind of thing. You'll see detailed stuff here. And we actually have a commit with a certain message. You'll notice that in the tutorial, the hash is different than the one you see there. That's pretty common. But yeah, the hashes will remain consistent inside of the Git repo as long as you don't edit the history. So next thing we could do is git add dot, and that's going to add the 3rd file, right? Because we have 2 already staged, and we haven't made any changes. So there's only 1 thing that needs to be committed, which is that file 3, and we could git commit source the line of catalyst, right? So I can just copy this over. Maybe not, whatever. Git commit. And something you might do is you might accidentally enter Vim. It's kind of a meme in the programming community that you might not be able to get out of Vim, so don't worry too much of it. So yeah, if you accidentally end up here in this place where it's like, I'm pressing things and they're not doing what I expect, press I, write your message. So after you press I, you write your message. Sourced third line of Catullus. Catullus 1. Cool. Then you hit escape, :WQ. You're never going to remember that. You're going to have to come look it up. But yes, if you do this often, you will remember. So that has created a commit. I've saved it. And I've made a typo. So this is great. I've done thrid line of Catullus. So how do we change that? Well, we can do git commit -- amend, which I can come in and I can fix that right there. Same thing, right quit. And if you do commit -amend, that will drop you into Vim, so you may need to know how to do that. Yeah. Then other stuff. Yes. We can look at our history. So git log. We have 2 lines of history now, which is cool. So if we were to git reset, or not git reset, if we were to check out this commit up here, then we'll be in a detached head state. Now what does that mean? Well, if we look at our git status, our head is detached, and if we look, we only have 2 files. We've gone back to the state of the repository back when there are only 2 files committed. But if we git check out the first commit, or the top commit in the branch, so that's pointing actually at main, then you can see that now we have 3 files. And so this is actually a really important point about Git. So if we go back and we check out this old commit, you can see that the actual state of the files on my computer have changed. If I go looking for, file 3, it's not there. And that's really good, actually, because that means that we can actually change which files we have, and we can edit the contents of the files to our heart's content, and we don't have to worry about losing any of the work along the way, because we can always just, go back to the state we were at main. And now you can see, file 3 is there, and it still has its contents, no problem. So that is really important. Another thing we could do is we're currently here on, if we check git status, it'll show where we're at. We're currently on branch main, and yeah, we have these 2 commits. But what if we want to edit this last one to add another line? So maybe we say, grab this one here, and we just write that in. So now we have a 4th file. So if we can check our git status, file 4 is untracked. We've got 4, and yeah, we haven't seen what's in 4, but there's a new line in there. Cool. So maybe we didn't want to create a new commit, because one option here is we could just go through the process again. We could say git add file4.txt, or if you didn't want to type all that out, you could just say something like this, git add 4, right? And if we check our git status, then yeah, that is staged for commit. So it would look like, yeah, we would have moved it in the same way we do here from the working tree into the staging area. So if we git reset, then it'll be back in the working tree and no longer in the staging area. So you can see untracked files, see it'll be committed. So git add, 4. Let's do that. So git status, nice. And then we git commit -- so if we wanted to make a new commit, we could have just do git commit -n, added a 4th line, but maybe it's sort of like we think that 3 and 4 actually belong together in some sense in the history. We can actually amend that previous commit. So we can git commit amend, and we had already amended once, but now we can amend it again, and we can sourced third and fourth line of catalyst 1, right? So now you can see down here, it says we have 3 and 4 being added to this commit. And now if we look, let's look at it with the stats, you can see that this commit actually contains 3 and 4. Now, it's going to be important, once you've pushed changes to a remote repo, you probably shouldn't amend the commits because it'll change the history and things will get all messed up. But when it's not pushed yet, you can actually go back and change things. And this can be really helpful if you realize you've made kind of a silly flub, and then you don't have to make like another dumb commit that is like, fixed silly mistake. You can just fix the mistake in the commit and never have it be visible in the project history, which is kind of nice. So it looks clean when we go back and try and figure out what's happening. So yeah, that's most of the basics for Git. So you're going to add things to your staging area, and then you're going to commit them, and you'll be building this chain of history. And yeah, that's going to be how we function in the basic way. So that's all for this one. See you in the next one.